All right, let's dive into one of the biggest, coolest ideas in all of science fiction, alien megastructures. We're talking about things like Dyson spheres, ring worlds, stuff so big it's hard to even wrap your head around. But are these things the ultimate destiny for any smart species out there, or are they just pure fantasy? Let's get into it.
So this is the big question, right? On one side, you've got these absolutely incredible sci-fi dreams of what a civilization could build, but on the other, you've got the cold, hard, unbending laws of physics. Which one wins? Honestly, the answer might totally flip how you think about our search for aliens.
Okay, so before we even get into hunting for megastructures, we gotta be real about how we're looking. And the truth? The picture of the universe we have is built on, well, a shockingly tiny pinprick of actual data. Now, don't get me wrong, it's amazing that we've found thousands of exoplanets, but you need to know how we find them. Look at the left column. What we actually measure are these tiny indirect things, a little dip in a star's light, a slight wobble in its position, and from that, we have to guess or infer everything on the right. Is it rocky? Does it have an atmosphere? Could it have life? It's all educated guesswork, not something we can actually see.
This quote just nails it. It perfectly captures our situation. We get all excited about these discoveries, but what we're really doing is looking at one single grain of sand through a straw and then trying to draw a map of the entire Sahara Desert. And that is the heart of what we call the resolution problem. We just can't see the details.
And this whole resolution problem leads us straight to the famous Fermi paradox. You know the one. If the universe is so vast, where is everybody? But I'm going to make the case that it's not really a paradox about aliens at all. It's a statement about our own cosmic blindness. First off, just remember the scale we're dealing with. About 400 billion stars. And that's just here, in our own Milky Way. The number of planets out there is probably in the trillions. I mean, the opportunities for life to pop up are just mind-boggling.
And our galaxy is just one of countless others. Think about a galaxy like IC 1101. It's a billion light years away. A billion! The light we're seeing from it today left before complex animals even showed up here on Earth. The scales of time and distance are they're beyond us.
So here's the kicker. What if IC 1101 is home to a massive Type 3 civilization that has engineered its entire galaxy? We would have absolutely no way of knowing. To us, to our very best telescopes, it would just look like another faint, fuzzy smudge of light. We couldn't pick out a single detail.
And this really gets to the heart of it. The great silence we think we're hearing, it might not be silence at all. It might just be the sound of us trying to listen to a symphony with our ears plugged. Our little detection bubble is just a tiny, tiny speck in an unbelievably vast ocean. And just like that, the paradox kind of vanishes, doesn't it? The problem isn't a lack of aliens. It's our profound lack of data. You've heard it before. Absence of evidence is not evidence of absence, especially when you've only looked at a single grain of sand on a beach the size of a world.
Okay. But let's say a civilization was closer, right here in our galaxy. Surely we'd see their giant megastructures then, right? Well, this is where the sci-fi party gets crashed by the laws of physics. And trust me, it's not pretty.
So you've probably heard of the Kardashev scale, right? It's this classic sci-fi idea for ranking how advanced a civilization is by how much energy it can use. Planetary, then stellar, then galactic. It's always presented like a ladder you're supposed to climb. But is it really?
Well, let's take a look at the reality check. A Type 1 civilization trying to use all its planet's energy? That would create catastrophic stress on the whole system. Heck, we're getting a tiny taste of that right now with climate change. A Type 2 building a Dyson sphere around its star? That would throw the orbits of every single planet into total chaos. And Type 3? It's just absurd. It's not a ladder of progress. It's a blueprint for total self-destruction.
Let's break down why. A solar system is in this really delicate gravitational dance. You start adding massive structures into that mix, and you throw the whole dance into chaos. A solid ring world is even worse. It's not stable. A planet is held in a stable orbit, but a ring isn't. Any little bump from an asteroid would send it careening into its sun. These aren't just tricky engineering problems, they're fundamental failures against the laws of physics.
And this is really the key thing to remember. A solar system isn't just a bunch of rocks floating around a star. It's an incredibly complex, interwoven system, like a delicate clock that's been ticking perfectly for billions of years. Trying to build a megastructure in it isn't like building a house. It's like taking a sledgehammer to the gears of that clock. So,
Does that mean all the epic sci-fi we love is just, wrong? No, not at all. It just means we need to know what we're consuming. We need to be able to tell the difference between plausible science fiction and glorious, unapologetic fantasy.
So here you have it, 2 different paths. On the left is the plausible route. Careful expansion, sending out colony ships, building smaller stations, harvesting energy in smart ways that don't break everything. Then on the right, you've got the grand fantasy, the stuff that looks incredible on a book cover, but, falls apart the second you run the numbers.
I love this. It's like a menu for sci-fi ideas. You can see right there, Dyson Sphere and Ringworld. The chaos risk is very high to catastrophic. Faster than light travel? Forget about it. That's impossible. But look at exoplanet colonies. Plausibility is pretty decent, and the chaos risk is manageable. That's where you find some really interesting grounded stories.
So what about the grand fantasy stuff? Is there still a place for it? Oh, absolutely. And this quote just hits the nail on the head. You can totally have your ring worlds and galaxy-spanning empires, but only if you decide physics is taking the day off.
And that's when you get heavy metal sci-fi. The kind of stuff where physics just goes on a coffee break and the only universal constant is how cool everything looks. This is Hathor riding her space pterodactyl while a guitar solo echoes through a nebula. The goal isn't to be accurate, the goal is to be awesome. And you know what? That is a totally valid and incredibly fun way to tell a story.
And that's really the bottom line, isn't it? You can have your hard sci-fi that respects the delicate clockwork of the universe, or you can have your glorious, over-the-top space fantasy where the only rule is the rule of cool. Because in that world, breaking physics is just part of a balanced breakfast.